In today's session, we'll be learning about how to make your own module and get it added in the Comdex chain. So for that, we will be using Ignite. Ignite is a tool, basically a CLI based tool, which helps you to add your own custom modules in any Comdex chain. Whether you want to create your own chain, add a module, add a function, Ignite is very handy and comes into use for each and every case. So anyone using Ignite for the first time, what you have to do, you have to just install Ignite. Here is the command. You simply copy and paste it in your terminal, and you'll have your Ignite. And after the Ignite is cloned into your desktop or system, you can just make install, like what we did for our own Comdex chain. So I have Ignite installed in my system. So when I click write Ignite and use this binary, we have a lot of options. The first one is scaffold, the second is chain, the third is generate account, relayer, tools, docs, version, help, completion, everything is there. So if you want to create a new blockchain, a module, or create a function that has some specific functions or message, you can create using this particular scaffold command, query, and many more things. If you want to build the chain means running your own chain. After creating your own blockchain, when you want to run it, you can do it by using this particular command. Then we have generate clients, API, docs from source code, then account, relayer. You can create a relayer using Ignite also. Like if you are not familiar with, actually there are two kinds of relayer which we mainly use. The one is Go relayer and another one is Hermes relayer. But also there is a TypeScript relayer, what we know as Ignite relayer. That is very handy, and you can use it or set up it very easily using the commands. Just by traversing through it, you can see the commands and set up your own relay. For example, first of all, I hope you all know what is a relayer. Relayer is basically a relayer is a basically a tool or a software that helps blockchain to communicate with between them. It's like a communication bridge for blockchains on a different platform, like a communication bridge between Comdex and Cosmos, Osmosis. So IBC transfer, we do IBC transfer, packet transfer, everything using relayers. So relayers are very important aspect for any blockchain on Cosmos ecosystem. So this one is relayer. So here you can configure the relayer and connect the relay. Everything is pretty straightforward and simple. So right now our focus is creating our own module on Comdex chain. So I have the Comdex repository cloned into my system, and the branch is, I'm on feature dev. I'm taking the latest pull. Okay, everything is updated. So what I will do, I will simply use Ignite and then scaffold. So here, what we can see, it's asking what do I want to do, or whether I want to create a chain, a module, a list, a map, single type, message query, anything. So my main focus is to create a module, right? So the module which we are creating and will be like developing in this session is a NFT module. Right now in today's session, my main focus will be how to create a app, module, register it in app.go and have it running in our Comdex binary. For example, if we see, so Comdex queue, we see a list of all the modules, right? Here is the token mint module, liquidation, bank, slashing, vault, market, and asset collateral. We don't see any module named NFT. So what we want to do, we want to create an NFT module and get it listed in our binary. So the complete process will be knowing in this session. So what I do, Ignite, scaffold, then module, and then we'll type help and see what are the params it takes. So it only takes the name, and it also takes dependency, like if you have a module dependency of bank module, account module, or any kind of module. And module, by module I mean the modules of Cosmos SDK, which are auth, params, gov, auth, these modules. If you want to use or initialize these modules while you are creating your module, using Ignite, you can use this particular dev flag and simply pass in bank or account, anything. So IBC just scaffolds a IBC module, and you need to pass in the name. And similarly, everything is pretty much straightforward and clear. So what I will do, I'll just create a module name NFT. That's it. So it's scaffolding. It takes some times and it's showing some error, but we don't have to worry about it. Anyways, our module is created, it's fast. So we'll just go and see if any NFT module is created or not. So right now we can see, yes, NFT module is created. It's a empty module, like there's nothing in this module right now. It's completely empty. When we go in query, we see no queries. When we go in query params, no params. In transactions, nothing. Everything is empty, right? In keeper also, everything is like, it provides a like structure, basic structure for the module, so that we don't have to initialize everything. Everything is already predefined, like a basic schema, we can say. Store is defined, everything is already defined. In message server, everything is defined. But we can see like most of the things are not resolved. It's showing message server unresolved, so we'll be resolving it. How you can do it, we'll know. Params also, in simulations, everything is empty. In types, everything is empty. In codec, what you do, you register your transactions, all the transactions that you are adding, you add it in codec and enable it for ledger transactions or any other kind of transactions. In error, what we do, we simply register all kinds of error that expect all kinds of expected error that can happen in this particular module. Like if someone is trying to deposit something else, then we'll show error and we'll register that particular error in this particular file, and we'll be calling that particular error while we are writing the logic of that particular function. Again, we have expected keepers. We have expect, like it's a simply, it's a example like how we are going to call the account, something from account keeper, something from bank keeper. Right now we can ignore this part, and we have something called genesis. So we have something called default genesis. When the chain is initialized, everything needs to be defined in genesis. Like we are initializing our chain, and right now we have asset module, so we are initializing asset in our chain. So that is done through this default genesis, and we define what we are trying to add in our genesis for that particular module. Then again, we have a keys.go. It is basically implementation of the KV store that we have in Cosmos SDK. Like for a particular key, we get a particular value, just like that. Then params, then types, everything is predefined. Here we have Genesis. We are like how the Genesis params are set and exported. Then we have handler. Handler is used for handling any types of transaction. For example, if we are creating any transaction, every transaction needs to be defined in this particular handler. And whenever a transaction is being called, it is being executed by this particular handler. The first like context passing, like the first flow of control is through this particular handler. The handler calls the function, and later on the function and its logics get executed and implemented. Then we have module. It contains like all the basic information of that particular module, its version name, its module name, and everything. And we can see, we if you are trying to like add any query or any transaction, we need to define its route through query route. and register services for query, register services for transaction. Everything needs to be defined in this particular module.go. And lastly, we have simulation. If we are writing any simulation for our particular module, how it's going to work, and all the logic are defined in this particular module simulation.go. Now, again, why all these things are not able to resolve? So for that, we already like learned in previous session that we have something called as proto. So we'll go and see the like why it's not being created or generated. So also, if you go to different modules, for example, if I go to lend module and in types, I see there are PB files, protobuf files. So all the proto which we create, and what we do through a script that's already predefined in our code, we generate PB files for that particular proto. So for lend proto, we have generated our PB files, and through this PB file, protobuf files, we are going to use it. We are going to use this particular struct in our code. We cannot directly use this proto in our code. So what we need to do, we need to run a script and convert this proto files into protobuf files, .pb files, right? So we see a NFT module is NFT directory is created here, and it has something called Genesis, params, query. Everything is empty, right? Transaction is empty, query is empty, only params that is also empty. In params is also empty, Genesis is also empty, containing only params. But it is not the correct schema like how we are going to store it. So when we go into this particular directory of comdex, we can see all the modules are predefined here. So what we'll do, we'll just move this particular NFT to this comdex directory, and we'll just refactor it. So now we have NFT. Now again, we follow basic schema of after asset, we add v1 beta 1. So defining the particular versioning of that particular module. Similarly, it's for every module. In auction also, we have v1 beta 1. So we'll follow the similar structure for that, and we'll add a v1 beta 1 directory here. And now we'll move everything in that particular directory. Takes a little bit of time. I think it's done. Now we have v1 beta, we have genesis.proto, params.proto. So again, the package name is not expected as expected. We'll see how it is there. It's comdex market v1 beta 1. Similarly, we'll do comdex NFT v1 beta 1. P dot v1 beta. Simply copy it and replicate it in all our modules. Proto files, sorry. So right now we have NFT, and also we have imported params. So we'll see how we imported things in previous module. For example, in Genesis, okay, we see the particular structure is like complex market v1 beta 1, what we actually define, and then market.proto. So similarly, we'll just copy and try to replicate it here. So not directly using NFT dot and NFT slash params.proto, we'll do market in place of market. What we'll do NFT. Okay. So convex NFT v1 beta 1 params.proto. We'll see anywhere else we are using this particular thing or not. We are calling any other files or not. importing any other files or not. Not here, not here. Yeah, here we are using here. Just replace it. V1, V1, V1 beta 1. And in transactions, nothing. So now moving to the third component, it says option go package. This particularly defines where our PB files will be generated and stored. So our PB files will be generated in X, NFT, and types. In the types directory, all our NFT .pb files will be stored and saved. So we'll have genesis.pb.go, params.pb.go, query.pb.go, and tx.pb.go. Just checking if we are missing anything. Let me see. NFT v1 beta 1. Everything seems fine. So now we have something called as scripts, and we have proto gen sh. What it does, it simply generates the proto buff file for that particular proto which we have written. So what I'll do, we'll just call this particular scripts. It's in scripts directory and then protogen.sh. Okay, and I think it needs a little bit refactoring. So it gave me a little bit of warning. Pagination is unused. We can ignore that part. And when we go to NFT and then in types, we see Genesis PB created, parents PB, query PB, and all the issues that were coming are over. We'll go one by one. Query, it's fine. Query params, everything is resolved. In transaction, everything is resolved. In query keeper, everything is resolved. Now we are not getting any single issue. So we are done with the initialization of the module part. Now again, what we'll do, whenever we are adding any feature and doing any changes in our code, the most important thing is to save that particular file and do a make install, right? So what we'll do a make install. It's saying to sync directly by typing go mod window. Okay, just let me do go mod id. Are there any changes? Okay, we ran into some issue. So, okay, there's some issue with the testing and the simulations thing. What we'll do, we'll just remove it for now. All the test files and simulations file and try to do it again. We'll just remove it for now. We can add the simulation and testing part later in next sessions. But for now, what we'll do, we'll just remove it and same go mod APIs system. What we'll do, we'll try to revert it. And now make install. So our binary is created. What we now need to do is we need to move the binary in our specified folder from where we are calling it. So we can simply check where is my comdex directory is situated. It's in user local bin. And right now, when I did make install, my binary was created at go get like, let me show you. It was created in go bin comdex. So what I'll do, I'll just sudo move it to user local bin and replace it. It'll ask for my password. Then now what I will do is simply write in comdex, sorry, comdex q or comdex tx. When I do comdex q, I don't see any NFT module, right? So what I will do means our initialization is still incomplete. So we need to do additional things. So what are they? We need to define our module in this particular app.go. It is a like basic structure for it is the main file for initializing all the module, their keepers and their handlers, right? So what I'll do, I simply copy the previous one and replace it with NFT, previous defined files, and T FT and FT and F and edit the name to NFT. So we have our types imported, NFT types and their path imported. Now what we'll do, so first one is get gov proposal handlers. So right now we are not having any governance proposals, so we are not adding it here. We are skipping that part. Now we move to module basics, right? So in module basic, we need to define the app module basics for each of the modules. So what was our last module? Last module was reward module. I'll just add it here. And ft dot app module basic. We defined it here. Again, moving. Now we need to add the keepers, right? So keepers, we have sort of vault keeper, market keeper, rewards keeper, ICS 20 keeper, 100 keeper. So what I'll do, I'll just define it after rewards keeper, because here we have IBC module and here we have our own module. So I'll just define it here, NFT keeper, NFT, sorry, NFT keeper is NFT keeper dot keeper. We defined our NFT keeper here. Now again, in new, we need to define its store key, right? So what I'll do, I'll just define it here. NFT types dot store key. It's defined here. Now again, we need to define the params keeper with subspace. What I'll do, I'll simply copy paste one thing and replace it names. It's replace it type with NFT types. I'll just copy paste reward types. Sorry, paste it here and replace it with NFT types. NFT types, and our module name is NFT. It's done. Now again moving to, and now the final task, what we can say, is to create our own keeper and put it here. So what I'll do, I'll just go for any custom keepers and Oracle keeper, liquidity, auction, collector, locker. Okay, I'll just copy paste this locker keeper, and after this reward, I'll replace it name with NFT keeper, and it will be NFT keeper dot new keeper. It's not resolving. I know why it's not resolving. We need to see what all things are in new keeper. In new keeper, we see we have binary codex, store key, mem key, and params type subspace. So moving back to app.go, we have this particular four things: app, param space. So what we'll do, we'll just copy param space, or right now we don't need it. So what I'll do, I'll just remove it from here only. Param style. Okay, it was having a users here. So we'll just go and just keep up this. Get subspace. What was the third thing? CDC, store key, mem key. Store key, and then we have mem key. Sorry. Mem key. Do we have any mem key there? No, we need to define it. So mem store key for like other modules are mem underscore reward. So we'll keep the same schema here also. It will be, sorry, I added it in locker v1. Sorry, my mistake. We have to do it in NFT keeper. In NFT, when we go to keys.go, we have mem store key. Okay, it was already defined. My bad. It was locker types. We have to make it NFT types. Everything is defined. Also, again, it's giving some error. Cannot use NFT keeper. Just a second. Type keeper, NFT keeper. So something is wrong here. NFT. Okay, it's calling the reference of the keeper. So we need to add. Let's see. Sorry. Now again, it's completely error free. Now again, the next thing what we have to do, initialize it again through the routes. So this one is proposal handler. So we won't be defining it here, but we also we have to add a manager here for that particular thing. Okay, so here is our rewards module, the last module. So what I'll do, nft dot new app module, and simply I'll just see what it requires: codec keeper, account keeper, bank keeper. App, sorry, app dot codec, then app dot nft keeper, then account keeper, app dot account keeper, and then at last app dot bank keeper. So everything is defined. We'll just put in a comma here. So our module manager is also defined, and now we have to set begin blocker and end blocker order. So what I'll do, I'll just call it at last nft types dot module name. Most of the things are defined through this particular module name only, that is nft, and we'll simply copy paste it because we have to do the same thing in end blocker also. After some type, we have our own, and also we have to set order init genesis. In genesis, how the ordering of this particular module should be. So what I'll do, I'll just go after reward, that was our custom module, and we'll add it nft types dot module name. We don't have to do any other thing. I guess we are good to go now. And we have this awesome keeper. We don't have to do anything in that. And let's say, everything is fine. Register API routes, everything is fine. Okay, so what this module account permission means, if you are using your module to have any minting or burning facility, like you want your module to mint any tokens or burn any tokens, you simply, what you can do is you define your module name here, and simply you can give it permission like odd types dot minter or burner for particular, like if you only want to mint it, you can just give the minter permission, or if you want to burn it, you can simply give the burning permission just like this. It's only burner, and someone like mint types is only minter. So you can define your module like right now I don't know what it's going to use, so I'll be defining it as nil nft types dot module name, and it's nil. And register upgrade handlers, this is used when we are upgrading our chain. That also will be learning in upgrade upcoming sessions. So but for for now we are good to go, but we see there are two errors. We'll go and see what are the errors. So nft in client is not being used right now, so I'll just delete it. And yes, we are error free. And what I'll do now is do make install again. So as I said, I did make install and my binary is created in Go bin condex. So what I'll do, I'll just replace it. So sudo move Go bin condex, and we are moving it to this particular directory, user local bin, password, done. Now when we type in condex, sorry, I need to add condex queue. We see NFT. So our NFT module is initialized in the context chain. But right now, if we do NFT, we won't be able to say any queries. Only params will be there, I guess. Yes, params is there because that was only defined in our code that we scaffold through that particular Ignite software. So only params is there, but that also is empty right now. So yes, this is how we have added a module successfully in our own Comdex chain. Similarly, for TXNFT, we right now don't have any commands, so it's coming empty. But in further session or in next sessions, we are going to learn about how to add particular this thing transactions. So this was it for today. In short, this was the complete process of adding your particular module in Comdex chain. Okay, then we can conclude here.